Good day, everyone. So today we're going to talk about science. Yeah. Before we start, I just want to give a shout out to this is called Sex Panthers. It was Victoria's mom's, and we get to display it in our pool room. And if you hear some rumbling, it's probably Maverick, our chinchilla. Say hi, buddy. As well as representing the APA of South Jersey. Woo! So, let's get into my electron theory. Now, there is no way to prove this with the amount of technology we have to observe these certain things, but let me just go through a few things with you right now and we'll just progress. I'm not saying that this is right. This is just something that I thought of that plausibly could be found out later on as our technology gets better in measuring and observing the things that we can't observe. You guys are probably used to seeing this in your science textbooks. So you've got your protons and neutrons and electrons. And that's the way we perceive it, and we're taught that these electrons go around in this orbit. And the protons and the neutrons are right in here. Well, that's just to simplify what's going on. What's really going on is this. So, our nucleus is here, and our electrons pop up everywhere, not necessarily in some sort of fixed orbit. Anytime that we take a moment to try to observe an electron, it could be here, it could be here, could be right there. So this is like a two-dimensional slice of what the atom looks like. But if we were to blow up the atom, enlarge the atom so we can actually see it, there's a cloud that is created around the nucleus from the electron just moving around in this bit of an orbit that it's magnetically attracted to. My theory is that the electron that's over here, when it's over here, it doesn't move in a line over this way. What it does is it jumps. It's from here to here to here to here to here to here to here. And this jump happens so fast that technically the electron teleports. So my theory is that the electron teleports at or faster than the speed of light within its orbit around the nucleus. Again, I'm not saying that it's right or it's scientifically true or scientifically proven, but it would be wonderful if it were proven one day. And I could take claim to it. It'd be called the Marquez Electron Theory. That'd be great. So the speed of light is 299,792,458 meters per second. Let's round up a little bit. 300 million meters per second. The speed of an electron, it can reach with enough charge 99.9999992% of the speed of light. So it is 8 billionth of a percent off the speed of light. Almost completely equal. And we can't actually see an electron. We can see something like, I think it's 200 nanometers long, and an electron is something like 30 nanometers long. But anyway, we can't actually see with our technology and our devices and our measuring devices. Instead, we measure where an electron is by the electromagnetic wave that the electron emits, the electric field that the electron emits. So what we're doing is we're hoping to look at a spot, and if it passes that spot, it alters that spot in an electromagnetic way, so we can sort of pinpoint where we think the electron would be, considering its effect on the rest of the space around it. According to quantum physics, there's this thing called the observer effect. By observing something, you alter the state in some manner, the state in which it is in some manner. By just looking at something or measuring something, we're applying some sort of pressure or some sort of altering effect to that thing that we're observing. So if I'm observing a hot spoon, let's say we're using a metal thermometer, I'm not getting the exact temperature of the spoon at that time because I'm applying a piece of metal to observe that temperature that is not the same temperature. And since the second law of thermodynamics explains that by putting something cooler on something hotter, the temperatures now have to even out. And in that moment, you're taking a degree of heat away from that spoon. So you're not actually getting a real reading because you're altering that temperature and of that spoon somehow by trying to measure it. Now let's take a look at light for a second. It's all going to come together. It's all going to make sense. Light is not a particle. It's a wave. It's a photon wave. It has no mass, but it somehow still has effect on other particles because it carries momentum, so it can push particles. That's how solar sails work. Okay, so light has no mass. It is a wave, not a particle. Sort of goes like this, travels, has no mass, but it can carry momentum. Using light, for example, to observe an object using the ideas of the observer effect require that light to hit an object and causes it to reflect that object, that particle, that atom, whatever, causes it to reflect that light. So even using light to observe a particle is going to push it out of the way because light has momentum. So using light to look at a particle that's over here, when that light comes in and bounces off, that particle is now over here. So even though we're trying to observe it, we've moved where it is. So now we're observing it here when we were trying to observe it here. Little interesting fact about observing electrons is when we observe these electrons, they're forced to behave like particles and not like waves. Now, that makes me think that if we're observing them as particles and we can't actually see what the hell they really are, maybe they are waves. Maybe they are like light, where it's a photon. They carry a certain charge, but what's to say that it's its own small, tiny dot of a particle? What if it is a little wave of a particle, just like a photon? We don't know. But when we observe it, we're forcing that particle to act like a particle and not like a wave. So whatever techniques we use to observe things, it's going to alter it. And observing things changes what occurs as well as changes our perception of what occurs. Now, according to science, that whole idea that photons have no mass but still have momentum, I don't know if quantum physics has a different way of understanding this, but you can't have momentum without mass. You can't have velocity without mass. And given enough electrical charge, overcharging an electron, it can reach the speed of light to 0.000008% off of what the speed of light is. So it can almost reach the speed of light from what we can observe. But what we can observe is flawed. That's why I would be wonderful if we found out at some point later on in life, I picked a different one, in science, that an electron coming from here to here didn't actually travel that bit of space in between, but rather teleported. To me, it makes a little more sense that to get from here to here to here to here to here to here in an atom that has 7 electrons, to have them spinning around in some sort of fixed orbit, they're going to crash into each other. Eventually, there's a chance for it to crash into each other. And what I've seen so far through science and nature, and at the atomic level, there's no mistakes. Those are the fundamental building blocks of what we are and everything that's around us. So what I'm saying is, we observe it here, we observe it here. We have never observed it traveling because we can't observe it traveling. I'm saying, what if it doesn't travel? What if the magnetic charge keeps it in some sort of orbit around there, but it moves so fast that it's not traveling a line from here to here, but rather being here, existing here, and then existing here, and then existing there, and then existing there. And they're all just existing and shooting all over the place, teleporting, basically, around the atom. Something to think about. That's my electron theory. Wanted to get it out there so I can move on and do some more videos, because there's a lot of other topics that I want to, talk about. But just something to think about. Something to ponder. That's all. The whole point of what I'm doing is just try to open up people's minds to things that may be different than what you're used to. Again, I have no scientific backing. I don't have a giant fucking microscope. I'm not splitting atoms. I'm just saying, what if? Given these parameters of science, what if? That's all for today. Take it easy, guys. Have a great day.